Hi everyone, let's solve binary search problem. Given an array of integer nums which is sorted in ascending order and an integer target, write a function to search target in nums. If target exists, then return its index, otherwise return -1. So simple approach to this problem is that we iterate over all the elements in the array and find out the element. If whenever we find that element, we will return its index. If the element is not present, we just return -1. In this case, the 2 is not present in the array, so we are going to return -1. So basically this is it, and it is a linear search algorithm, and it basically you are iterating over every element, so the time complexity of the algorithm will be big O of n. But the constraint here is that you must write an algorithm with big O of log n runtime complexity. That is the constraint here. So let's try to understand binary search. So for the same reason, I have just copied all the elements over here, and now let's also give indexes for all the numbers here so that we will be able to debug it better. Right, now let's also write the binary search algorithm this side. So when can we apply binary search is that if okay, let's first explain binary search. Binary search is nothing but if there is a whole search space and you are able to, based on some condition, divide the search space into two parts and then discard one part of it and find answer in the remaining part of it. So basically reducing your search space by half is nothing but binary search, right? That's how it works. And how will you find, there will be a way how you find your midpoint and then discard one part of it. Okay, and when can we apply binary search? It's mostly when the array is sorted and there is a way for you to figure out which side of the mid pointer you can traverse and get the answer, right? Okay, let's clear this off. I hope the explanation is clear. Now these are the elements and these are the indexes. So how binary search works is that my low pointer will be at the minimum and high pointer will be at the maximum index of the given array. So in this case, my low is here, high is here, mid is here, let's say. Now let's find out. So low is 0, high is 5. How can I find calculate mid is 0 plus 5 by 2, nothing but 2. I'm just taking the floor of this value, and now I am at index 2 and I am here at 3. So my mid is okay. So basically I got nums of mid less than target, right? So basically if I am at this index and my target is greater than my mid index, which side should I traverse? I should be traversing on the right side because I know that this is a sorted array and my answer is greater than the mid value 3, right? So I will be discarding this entire array, basically this also, and moving forward from here, right? Why am I also discarding the mid value is because I know that this is not an answer, so along with this I will be discarding all these values. Now what did I do? If my nums of mid is less than target, I have moved my low to mid plus 1, because since mid is not the answer and I know that the answer will not be on the left side of it, I have moved my mid. Now let's consider yeah, now our mid is 2 and now my low is pointing to mid plus 1, nothing but 3, and my high is still pointing at 5. So now 3 plus 5 will be 8 by 2 will be 4, right? Now my mid pointer is pointing at this place and I will check nums of mid is equal to target or not, right? There will be, let's say, nums of mid greater than target and nums of mid target. So we found that this is the case. When I find that nums of mid is equal to target, what am I currently doing? Basically I will return the mid index, right? That is all I will do from here. But if, let's say, if the other way around, what will I do? I will just do mid minus 1, because I am sure that the answer is not on the right and the answer will also be not mid, so I will move on to the left side. So moving left side will be high equal to mid minus 1. Okay, we found the answer. Let's take one more example. Instead of target being 9, let's go and find 2, right? So my initial will be, low will be here, high will be here, which is same. 0 plus 5, 0 plus 5 by 2 will be 2. So my index will be this thing. And now my mid is index 2, and the element which I'm trying to search is 2. So which side I should be moving? I should be moving on to the left side, because I know that 2 is less than 3, right? Nothing but this case. So I am moving high equal to mid minus 1. So in this case, what will happen is, basically this will be 0 and this will be 1, right? And now I will be moving, or I'll be calculating the mid. So 1 by 2 is 1. Basically 0, because we are taking the floor of it. So 0.5 floor will be 0. So my mid is 0. I will again check if this is my mid value now. I'll check nums of mid is equal to my target. No, it is still lesser. So again I have to move my high pointer to mid minus 1. So it's low is still 0 and high I have to move from mid minus 1. It is nothing but minus 1. So should I still continue my search space, because we have already crossed it? So we should not. So the condition will be, as long as my low pointer is less than or equal to high pointer, I have to iterate. Why? Because if low is pointing to the lowest index and high is pointing to this, if my high is moving this side and low is moving this side, whenever they cross a point, that means you have already traversed all the elements and there is no answer. So basically your condition should be this. Now once this is done, if you still did not find an answer, you should return minus 1, right? This is the binary search algorithm. Now let's try to code this problem. So for this, what can I do? First, let me assign low to 0. Let high is equals to nums dot length minus 1. So now I will have to iterate low less than or equal to high, and mid is equals to math dot floor. As I discussed, we will be taking floor of it. Low plus high by 2. This is what we have to do. Now once we get the mid, if nums of mid is equal to target, simple, what will we do? We will return our mid. Else if nums of mid is greater than target, what will be? Nums of mid is greater than target, high is equals to mid minus 1. High is equals to mid minus 1. And else, we don't really have to write a condition here, because we have already covered 2 conditions above, and there will be only greater than, less than, or equal to. These are the only possibilities here. So let's return minus 1 from here, because obviously if there is no value found, we will return minus 1 after the loop ends. And this condition, we have understood that once low crosses the high point or high crosses the low point, that means you have already traversed all the elements. So let's run this problem first. Yeah, it's accepted. Now let's submit it.